technology had improved in those 2 centuries. And in 1983, the National Bureau of Standards, using a laser technique, measured the speed of light as 299, 792, 0.4586, plus or minus 0.00003 kilometers per second. In other words, very, very small error band. But what's interesting, if you stand back and examine these numbers, you'll notice that the means don't even overlap. That Harvard's analysis fell outside the error band of Romer's and all the way down. So a Canadian mathematician by the name of Alan Montgomery analyzed all this data statistically, and he also concluded that the speed of light's been slowing down. In fact, it follows a cosecant squared curve with better than a 99% correlation factor. Now, this implies that the speed of light's been slowing down. And if you go backwards and say, okay, what was it earlier? It was apparently 10 to 30% faster in the time of Christ. It was twice as fast in the days of Solomon. It was 4 times as fast in the days of Abraham, and 10 million times faster prior to 3000 BC. And incidentally, there are similar trends in 475 measurements of 11 other atomic quantities by 25 different methods that imply the same thing. It's interesting that some years ago, of course, we developed a friendship with Barry Setterfield, and we have included many of these discoveries in our materials, and got a lot of guffaws from some of my friends, Christian physicists, that felt that tried to advise me, Chuck, don't buy into that. That's foolishness. Any physicist knows that the speed of light's a constant. It's not variable. And we caught a lot of criticism from some of these friends for a number of years, better part of 10 years. But in the last 2 years, there have been a number of articles in reputable scientific journals where they have now discovered the speed of light is not a constant. One of the things that disturbs me about these articles that you find in the press is there are many of them now that recognize the reality that the speed of light is a variable and has been slowing down. What's disturbing that none of them acknowledge the pioneering work of Barry Setterfield and Trevor Norman, who've taken this abuse over the decades. You'll discover that physicists cling to their beliefs with the same tenacity that theologians do. And it's not at all objective. But let's get into some other confirmations. The French Astronomical Journal back in 1927 suggested some of these things. Tom Flandern at the U.S. Naval Observatory noticed that the atomic clocks are slowing down relative to orbital clocks. And there's some Russians also that have published in this area independent of Setterfield. So this is not a harebrained idea of a couple of Australians. It's very real. Now, the definition of time itself changed in 1967. Up until 1967, a second of time was defined in terms of one Earth orbit around the sun, a small fraction of that, obviously. After 1967, the second was redefined as a number of oscillations of the cesium-133 atom. And see, if atomic clocks are correct, then the orbital speeds of Mercury and Venus and Mars are increasing, which of course is impossible. If the gravitational constant is truly constant, then atomic vibrations and the speed of light are decreasing. And see, if a planet's orbital speed is increased, it would violate the law of conservation of energy. If atomic clocks are correct, the gravitational constant would change, and no such variations have been detected. So this has some profound implications in terms of the very fabric of our reality here. See, if atomic frequencies are decreasing, then 5 properties of the atom, such as Planck's constant and others, would also be changing. And statistical studies support both the magnitude and direction of these changes. There's another thing that's happening in the field of physics you should be sensitive to. All this, bear with me, this all will affect your perspectives as you read. The more you know about what's going on in science, the more comfortable Genesis 1 reads. There's a thing called Hubble's law. That's why the Space Telescope was named after Edwin Hubble. Hubble's law was that that because they observe that the spectra, the light spectra of stars, shift to the red, and apparently shifts to the red in proportion to its distance away, they've always assumed that that was like a Doppler effect. A siren sounds higher pitched as it comes at you and lower pitched as it moves away. They call that the Doppler effect in sound. They felt the same things happening with light, that the light shifted to the red because these things are moving away from us, longer wavelength. Except a couple of guys, Halton Arp in Germany and William Tift in the University of Arizona, have spent the last several decades collecting data, precise data about the red shifts. And they've discovered that some of them aren't so well behaved. See, Hubble's law postulated that this whole idea that the red shift is caused by an expanding universe. And that's why he's honored by the space telescope being named after him and so forth. Except William Tift has discovered that the red shifts are quantized. They're always a multiple of a definitive number. In other words, sort of like the keys of a piano. You can only get certain keys by hitting the key, unlike a violin where you can get any tone you want. The piano, you've got discrete choices. The red shift has that character. In other words, it's digital. And so it turns out that the red shift may actually be evidence of a change in the fabric of space itself. It's an atomic effect rather than a recessional velocity effect. That's just a conjecture at this point, but you should understand the whole field of astronomy is based on Hubble's law, and the rug's been pulled out from under that. Well, going on in Genesis, God said, "Let there be light," and there was light, and God saw the light that it was good, and divided the light from the darkness, and he called the light day, and the darkness he called night. And the evening and the morning were the day one. The subsequent days are relative. It's second day, third day, fourth day. But this one has a unique designation. It is the first in existence, the first, day one. And also God divided the light from the darkness. We could talk a lot about that. Most of us think that darkness is simply the absence of light, except now we discover that darkness itself has a property. That's why we have black holes. You can have a gravitational effect out of which no light can emerge. So it's not as simple as it first seems. But there's another thing I want to call your attention to. It says the evening and the morning were day one. The word evening in Hebrew is erev, and the word morning is boker. And we understand evening and morning, erev and boker, to be evening and morning, because that's its usage in modern Hebrew. But we'll run into a strange event when we get to the seventh day, because there is no evening and morning. And that's a clue, perhaps, that the word erev and boker in its original context meant something other than evening and morning and came to mean evening and morning subsequently. Let's explore these two terms a little more carefully, because neither of these occur on the seventh day. Erev actually speaks to obscuration, like a mixture. Mathematically, it's increasing entropy. When encroaching darkness began to deny our ability to discern forms or shapes and identities, hence this became a term for twilight, a time of approaching darkness or ambiguity, confusion. So Erev had its initial concept of obscuration, and that's what's a natural term for evening twilight, if you will. At sunset, that marks the duration of impurity, when a ceremonially unclean person became clean again. So we'll discover that the demarcation in the Hebrew world was Erev, the evening, not midnight or morning as we think of it in our world. So the Erev became the beginning of the Hebrew day, but it's a term for evening, because it's a time when there's encroaching darkness and so forth. Okay. The word boker is just the opposite. Boker really means becoming discernible, distinguishable, visible, the perception of order. It's as if you're getting up in the morning and you can begin to see, gee, there are things out there. Let's say if you've ever arrived very late at night at some strange place and went to bed, then in the morning you get up and you look around and you begin, wow, I didn't know that mountain was there. That as the light comes, you can begin to discern. So that's mathematically a form of decreasing entropy, of decreasing randomness. So it has an attendant ability to discern forms, shapes, distinct identities, breaking forth of light, and revealing things, in effect. So that's why it comes to mean dawn or morning. I'm going to suggest to you that these terms have a more fundamental meaning and have come to colloquially mean evening and morning. So we need to understand one of the sciences that's emerging in modern times is probably the most telling of all the sciences, and that's the information sciences. As we understand communication theory, information theory with computers and the rest, and that's been, of course, my personal field of specialization. We obviously can think of disorder and order. We all know what order looks like. We know what disorder looks like. On a Saturday, you clean up the closet. Or at school, you clean up your locker every once in a while. You go from the confusion, you try to get things a little bit more organized, or a woman's purse, whatever. There's a thing called noise, useless change, in contrast to signal, which is carrying information.